When you think about smart glasses, you probably picture some high-tech billion-dollar lab, right? Well, forget all that. The story we're diving into today, it starts in a teenager's bedroom with just a huge idea and a really, really tiny budget. So let's get into it and see how he pulled it off. All right, let's talk about the $40 smart glasses. Meet Abrar Farouj. He's a 10th grade student who, like a lot of us, saw Tony Stark's Edith glasses in the movies and thought, wow, I want those. But instead of just waiting for the future to happen, he decided, you know what? I'm just going to build it myself. And his goal was, well, it was pretty ambitious. He didn't just want to build any smart glasses. He wanted to build a pair that was powerful, for sure, but also incredibly cheap. I'm talking a whole world away from the $1,000 plus price tags you see on the commercial ones. So, what did his first working prototype actually cost him in the end? Get this, $34.50. I mean, that's just mind-boggling, right? That number is so amazing because it totally proves that the basic tech you need to create a heads-up display is way, way more accessible than most of us probably ever thought. Okay, so how on earth did he do it for so cheap? Well, the secret is there's no secret really. These aren't some exotic custom-made parts. What you're looking at is basically a shopping list for any tech hobbyist. You've got a Raspberry Pi Zero for the brain, a tiny little OLED screen, a USB mic. I mean, this is all stuff you can buy right off the shelf. So we're deconstructing the dream here. How do these things actually work? Abrad's project is without a doubt a brilliant piece of DIY ingenuity, but what's really fascinating is that all smart glasses, I mean from his $40 prototype all the way up to the most advanced commercial ones, they're all built on the exact same fundamental principles. So let's break down what those are. Okay, first up you've got what's called the optical engine. This is pretty much the heart of the whole system. It's the component that creates the digital image you see. In Abrar's DIY version, it was just a tiny OLED module, one of those super thin high-contrast screens. Fancier systems might use something like a Pico projector, but the job is the same: make the picture. Now, if you look at a commercial product like, say, the original Google Glass, they used this really clever trick. Instead of just projecting onto the lens, they had a tiny display that shot light into a little prism. And that prism's job was to bend the light just right, aiming it directly into your eye. The effect? It creates this perfect illusion of a screen just floating out in front of you. Super smart. All right, next piece of the puzzle is the combiner. This is where the real optical magic happens. It's the part that lets you see both the real world and the digital stuff at the same time. Think of it like a special mirror. It has to be clear enough for you to see through it, but also reflective enough to bounce that digital image from the optical engine right into your eye. It's a delicate balance. And this is where Abrar's solution was just beautifully simple. He didn't use any fancy curved mirrors or anything. He just took a flat piece of glass and tilted it at 45 degrees. Then he angled his little OLED screen just so that its image would bounce perfectly off that glass and into his eye. It wasn't about expensive optics. It was just about clever, simple geometry. Genius. And finally, of course, every pair of smart glasses needs a processing brain. This is the computer that runs the whole show. It's what's processing all the data, handling Wi-Fi and Bluetooth, and telling that optical engine exactly what picture to create and when. It's the boss. Now, this brain usually comes in one of two flavors. On one hand, you have a microcontroller, like an Arduino. These are great for simple tasks. They're low power, easy to use. But if you want to do anything with complex graphics or AI, well, you're going to need more horsepower. That's where a single-board computer, or SBC, comes in. Think of it like a tiny credit card-sized computer, just like the Raspberry Pi that Abrar used in his project. All right, now for the DIYer's dilemmas, and this is where it gets tricky. We've just established that the basic parts are cheap and pretty easy to get, so why isn't this technology everywhere? Why don't we all have a pair? Well, let's get into the massive challenges that every single smart glass designer runs into. Yeah, I mean, that's the big question, right? If a teenager can whip up a working prototype for less than $40, why are we all still waiting for that perfect pair of smart glasses to hit the market? The answer, well, it has to do with a brutal, unavoidable fight against the laws of physics. I mean, just think about it for a second. What do you want from a pair of smart glasses? You want them to be lightweight, right? Comfortable? You want the battery to last all day. But you also want them to do really complex stuff, like recognize faces or objects in real time. And here's the problem. You just can't have both. A powerful processor needs a big, heavy battery, and it generates a ton of heat. Suddenly, your sleek glasses turn into this hot, heavy, power-sucking mess on your face. It's just physics. And look, the hard data absolutely proves this. Researchers at Carnegie Mellon ran a test. They tried to do a simple character recognition task on the glasses themselves. The result? It took over 10 seconds per image and burned through 12.8 joules of energy. But when they offloaded that exact same task to a server nearby, it took just 1.28 seconds and used only 1.14 joules. I mean, the difference isn't just big, it's absolutely staggering. It's a night and day comparison. So this brings us to a smarter architecture, and really the only logical solution. If you can't do the heavy lifting, the tough computation on the glasses themselves, you've got to do it somewhere else. You have to offload it. But wait, you might think, just send it to the cloud. The problem is sending it all the way to some distant cloud server and back is just way too slow for real-time stuff. The lag would be awful. And this is where this really cool concept of a cloudlet comes into play. Just imagine a small but powerful server like a data center in a box that's located really close to you. Maybe it's in the same building, or even just on the same Wi-Fi network. It's the perfect middle ground. You get all the processing power of the cloud, but because it's so close, you get it with almost no delay, super low latency. So the new architecture is actually pretty simple. Here's how it works. Step 1. The glasses, the wearable device, they don't do any thinking. They just capture data, like a video feed. Step 2. They send that data to the nearby cloudlet. The cloudlet does all the heavy computation, like face recognition. And step 3, the cloudlet sends a tiny, simple result back to the glasses. And it happens almost instantly. The big, faraway cloud, that's only used for stuff that isn't urgent, like logging data or whatever. And really, this is the key to making the whole thing work. You keep that communication loop between the glasses and the nearby cloudlet super short and super fast. That's what gives you that crisp, interactive feeling you need for augmented reality. And the best part? The glasses themselves get to stay lightweight, cool, and energy efficient. It's the best of both worlds. Okay, so we've talked a lot about the tech, but why does all this technical wizardry actually matter? What's the human impact? Because when you solve these massive engineering challenges, you're not just making cool gadgets anymore. You're starting to create tools that can genuinely, profoundly change people's lives. I mean, think about this. Over 20 million Americans are affected by some form of cognitive decline. This could be from a traumatic brain injury, Alzheimer's, or a stroke. And for them, daily tasks that a lot of us just take for granted, things like remembering someone's name or a simple to-do list, those can become huge, immense challenges. The researchers at Carnegie Mellon painted this incredibly powerful picture. They gave a hypothetical scenario about Ron, a veteran with a brain injury. Imagine this. Ron is wearing a pair of these smart glasses connected to a cloudlet. They see what he sees. So when he looks at a person for just a few seconds, that person's name is whispered in his ear. When he glances at his houseplant, he hears a gentle reminder, "Water me." The glasses aren't just a screen anymore. They've become a real-time cognitive assistant, helping him navigate his world. And that's the ultimate promise of this technology. It's a journey that starts with a teenager tinkering with a Raspberry Pi and ends with a technology that doesn't just augment our reality, but has the potential to help us connect with it and remember it more deeply than ever before.